Today we're diving into a paper that explores a novel approach to improving multimodal chain of thought reasoning. The paper are Alternating Reinforcement Learning and Supervised Fine-Tuning for Enhanced Multimodal Chain of Thought Reasoning through Diverse AI Feedback proposes a two-stage algorithm that leverages feedback from advanced AI models to enhance reasoning capabilities. Let's start with the core problem this paper addresses. What are the limitations of existing methods for multimodal chain of thought reasoning?
Existing methods for multimodal chain of thought reasoning often rely on ranking-based feedback, which can overlook valuable information within generated outputs. Additionally, the reinforcement learning RL process used in these methods is inherently unstable and requires extensive hyperparameter tuning, leading to potential degeneration issues like repetitive words and incomplete sentences.
So ARES aims to address these limitations. Can you explain the two-stage approach proposed in the paper?
ARES alternates between two stages: reinforcement learning, RL, and supervised fine-tuning, SFT. In the RL stage, the model receives sentence-level feedback from an advanced AI model, such as GPT-4 or Claude 3 Opus, which scores each sentence based on its contribution to solving the problem. This provides more granular rewards for the RL procedure compared to ranking-based feedback.
This sentence-level feedback seems like a significant improvement. How does the SFT stage complement the RL stage?
The SFT stage addresses the instability of RL by using the advanced AI model to correct minor errors in the RL fine-tuned model's outputs. This correction feedback helps stabilize the model and ensures that the RL-induced changes are properly reflected without requiring extensive hyperparameter tuning.
It sounds like ARES effectively combines the strengths of both RL and SFT. What are the key advantages of using an advanced AI model as a teacher in this process?
Using an advanced AI model as a teacher offers several advantages. First, it eliminates the need to train a separate reward model, which can be computationally expensive. Second, the teacher can provide accurate feedback even when the model generates outputs that are out of distribution, which is a common challenge for trained reward models.
The paper mentions that RLS was evaluated on two multimodal datasets, Science QA and OKVQA. Can you elaborate on the experimental setup and the evaluation metrics used?
The experiments were conducted using two different model sizes, Flan Alpaca Base and Flan Alpaca Large, trained on both Science QA and OKVQA. The rationale reasoning quality of ARES was compared to the baseline model, multi-modal COT, MMCOT, using GPT-4o as an evaluator. The win rate, which indicates the percentage of times RU's rationale was judged better than MMCOT's, was calculated. Additionally, the impact of improved rationale reasoning on answer accuracy was assessed for both model sizes and datasets.
What were the key findings of the experiments? Did ARES demonstrate significant improvements in rationale reasoning quality?
The results showed that ARES achieved a win rate of around 70% against the baseline models for both datasets. This indicates that ARES consistently generated better rationale chains compared to MMCOT. Furthermore, the improved rationale reasoning led to a 2.5% increase in inference answer accuracy on average for the different model sizes and tasks.
That's a substantial improvement. Can you elaborate on the specific emergent behaviors observed during the RL stage?
The RL stage exhibited several interesting emergent behaviors. First, the models started generating rationale reasoning for problems that lacked such data in the original dataset. Second, the model began to explain why other options were not the correct answer, demonstrating a more comprehensive reasoning process.
The paper highlights the importance of the SFT stage in correcting errors introduced by RL. Can you provide some examples of how the SFT stage addressed these errors?
The SFT stage effectively corrected errors like repetitive sentences, truncated sentences, and incorrect content. For instance, if the RL stage generated a rationale with a truncated sentence, the SFT stage would provide a corrected version with the complete sentence. This ensured that the model's outputs were grammatically correct and conveyed the intended meaning.
The paper also discusses the challenges of incorporating external knowledge into the model. Can you elaborate on these challenges and how they relate to the AOK VQA dataset?
The AOK VQA dataset contains questions that require knowledge beyond what is visually apparent in the image. For example, some questions require knowledge about specific domains, like bicycle maintenance or livestock tagging systems. This poses a challenge for the model, as it needs to access and integrate external knowledge sources to provide accurate rationales and answers.
The paper mentions that our ARES is designed to aid the RL procedure without requiring extensive hyperparameter tuning. Can you explain how this is achieved?
ARES achieves this by using the SFT stage to guide the RL process. The correction feedback provided by the teacher helps stabilize the model and ensures that the RL-induced changes are in the desired direction. This reduces the need for extensive hyperparameter tuning, which can be a significant burden for large models.
The paper concludes by highlighting the potential of utilizing diverse types of AI feedback for improving multimodal reasoning. What are some potential future directions for research in this area?
Future research could explore more sophisticated methods for incorporating external knowledge into the model, such as using knowledge graphs or external APIs. Additionally, researchers could investigate the use of different types of AI feedback, such as providing explanations or generating alternative rationales, to further enhance the model's reasoning capabilities.
To wrap up, can you summarize the key contributions of this paper?
This paper proposes ARES, a novel two-stage algorithm that leverages diverse types of AI feedback to enhance multimodal chain of thought reasoning. ARES effectively combines the strengths of RL and SFT, achieving significant improvements in rationale, reasoning quality, and answer accuracy. The paper also highlights the challenges of incorporating external knowledge and suggests potential future directions for research in